Is the Earth flat? This video aims to give an unbiased answer to this question. We want to take the flat Earth model seriously. And to check whether a model accurately reflects reality, we look to see whether it makes predictions that we can then verify with observations. We try to avoid difficult mathematics and want to refer to directly observable facts. If the observations agree with the model's predictions, that speaks in favor of this model. If they do not agree, then the model is refuted. But this already presents a difficulty. There are various models of a flat Earth, some of which contradict each other. We will therefore only take its basic elements, as they are most widely accepted among the proponents of the flat Earth theory. This includes the Earth as a circular disk surrounded by a ring of ice, which is identified with Antarctica. There are different ideas about what lies beyond this ring of ice, however, this is irrelevant for our question here. The North Pole is in the middle of the Earth's disk. The so-called latitudes are arranged in a circle around the North Pole. Places with the same latitude have the same distance from the North Pole. A special latitude is the equator, where this distance is almost exactly 10,000 kilometers, 6,218 miles. In order not to make things unnecessarily complicated, let's consider the case where the sun is exactly above the equator. The observer there sees it directly above himself at noon, at the zenith. This happens exactly in the time of year when day and night are of equal length, so sunrise is 6 hours before local noon and sunset is 6 hours after it. This event is called the equinox, and it happens twice a year, around March 20th and September 23rd. Proponents of the flat Earth model have calculated that the sun must then be about 3,100 miles above the Earth, this are 5,000 kilometers. This is correct if you measure the height from the 45th parallel with the assumption of a flat Earth. This procedure was also described by the well-known proponent of the flat Earth theory, Samuel Rowbotham, in his work Zetetic Astronomy. Maybe I'll explain this in more detail in another video. Now we have a functioning model of the flat Earth, with the sun's path above the Earth. Let's go down to the surface of the Earth, to the equator. We want to see how, according to this model, the sun's path can be seen from Earth. To simplify things, I have left out distracting things like mountains, forests, and buildings, but also the stars. So now it is midday, on an equinox day. The sun is directly above us. Now the sun moves on. After 6 hours, the day ends with sunset. Where is the sun now? Because the sun goes around a circle once in 24 hours, it has made a quarter of a circle in 6 hours. This means that the observer sees the sun exactly in the northwest. Night falls and for some reason, the sun is no longer visible from us. But we know that it continues to move along the equator, because on the other side of the Earth's disk it is now day, and the people who live on the equator see the sun exactly above them. We are still at the equator, at equinox. After 12 hours of night, the sun rises, that is, it becomes visible again. In the meantime it has completed a semicircle, so that the sunrise now takes place exactly in the northeast. So these are the movements of the sun in the flat Earth model. But is this also what the observer sees in reality? Let's look at this photo. It was taken on September 22, 2024 in Washington, D.C., and published by the Washington Post. It shows the Washington Memorial and the Capitol in line with the rising sun. This means that the sun rises exactly in the east. And if anyone thinks the photo is a fake photo, take a trip to Washington and see for yourself on September 22nd, or March 20th, where and when the sun sets. The fact is, everywhere on Earth where you can see sunset or sunrise, on the day of the equinox the sun rises exactly in the east at 6 a.m. and sets exactly in the west at 6 p.m. According to the flat Earth model, however, it should be visible in the northeast or northwest at these times. It is clear, the prediction of the flat Earth model does not correspond to reality. The flat Earth model is wrong here. Here is the same thing again with a view from above at the time of the equinox. The red arrow shows the places over which the observer on the flat Earth would see the sun. If the Earth were flat, an observer at the equator would see the sun exactly in the northwest at sunset and in the northeast at sunrise. In reality, however, the sun sets exactly in the west and rises exactly in the east. This is shown here by the green arrows. It is clear, the prediction of the flat Earth model does not correspond to reality. This model of a flat Earth must be rejected as false.